So we have question number 10.3 and the question says ki if first question is the refractive index of a glass is 1.5. What is the speed of light in glass? A speed of light in vacuum is 3 into 10 to the power 8 meter per second. Okay. And the second is the speed of the light in glass independent of color of light? If not, which of the following two color red and violet travel slower in a glass prism? Okay, so let's solve this question. And in the first half, you can see that there is a given a refractive index of glass and the speed of light in the glass, right? So let's solve this. First of all, what is given? A speed of light in glass, that is given that refractive index of glass is 1.5 and the speed of light in vacuum is 3 into 10 to the power 8 meter per second. As we know that mu is equal to c by v, that is the speed of light in air by speed of light in that medium, and v is equal to c by mu g you can calculate, and that is 2 into 10 to the power 8 meter per second. That is the speed of light in the medium glass, right? So you have calculated that first part you have calculated. And now second part. In second part, what is it is said that does both the color have same going to be same speed in the glass? The speed of glass is the speed of light in glass independent of the color of light. क्या जो लाइट हम लोग यूज करेंगे, जो आपका जो विजुअल रीजन है उसमें विवग्योर जो है क्या इसके लिए हर एक अलग कलर के लिए आपका स्पीड ऑफ लाइट एक सेम ही मीडियम में अलग अलग होगा, ये बताना है। तो ऑब्वियसली हम जब लाइट की बात करते हैं तो हम वहां पे अप्रोक्सीमेशन ले लेते हैं कि वेवलेंथ सेम ही होगा, बट ऐसा नहीं है। लाइट भी आपका एक पर्टिकुलर एक आपका बहुत सारा वेवलेंथ कंटेन करता है, राइट? अलग अलग वेवलेंथ कंटेन करता है। दैट इज योर फ्रॉम 3600 एंगस्ट्रॉम टू 7800 एंगस्ट्रॉम। तो इसमें बहुत सारा वेवलेंथ आता है, राइट? तो उसी तरह से आपको ये समझना होगा कि हर वेवलेंथ के लिए जो स्पीड होने वाला है वो अलग अलग होने वाला है। और इसी कारण हम लोग एक बहुत इंपॉर्टेंट कॉन्सेप्ट पढ़ते हैं, दैट इज डिस्पर्सन। और इसी कारण हम लोगों को प्रिज्म में अलग अलग लाइट दिखता है, राइट? सो इसमें होता क्या है कि आपका जो डिपेंडेंसी ऑफ स्पीड ऑफ ऑन कलर ऑफ लाइट है, ये आपका एक ही मीडियम में अलग अलग लाइट मीन्स क्या हुआ कि आपका अलग अलग लाइट का अलग अलग वेवलेंथ होता है। तो अलग अलग वेवलेंथ के लिए स्पीड जो है एक ही मीडियम में अलग अलग होगा, और अलग अलग वेवलेंथ के लिए जो आपका रिफ्रैक्टिव इंडेक्स है ऑफ अ मटेरियल वो भी चेंज करेगा। हमें लगता है कि रिफ्रैक्टिव इंडेक्स ऑफ अ मटेरियल कांस्टेंट होता है, बट वो लैम्डा के हिसाब से चेंज करता है। एक ही चीज कांस्टेंट है, दैट इज फ्रीक्वेंसी। In this whole system, the only one thing that is constant is frequency, and that is fixed by the source from where the light is or the EM wave is initiating, right? So frequency is the only thing that is constant. Other than that, wavelength changes, the speed of that wavelength changes in medium with changing wavelength, and the mu changes with respect to different wavelength. Right. So this all three are variable with respect to changing wavelength, right? So that's why we see your dispersion phenomena. And what happens is the refractive index of same medium has different value for different lambda, and lambda and mu determines the speed of the particular light. So lambda is equal to your, as you know the formula, that lambda is equal to v by mu, right? So v by mu is your lambda, v is equal to v by mu, right? So speed of that in the medium by your frequency, right? So that's why we can see that that v is changing as the lambda are going to change, because nu is constant, frequency is constant, right? So that's why. So now let's see, once you have know the basic concept of this, you can now understand this clearly, that for shorter wavelength in this situation, violet, let's assume the wavelength of violet is lambda v and red is lambda r, longer wavelength. Red is having longer wavelength and violet have shorter wavelength. Okay, so now what happens is, since mu is equal to c by v, as we all know, and your lambda is equal to a speed of light, or a speed of that wavelength in the medium by frequency in the medium, that we know, v by nu. Okay, now from here you can compare it. As we know, lambda v is shorter wavelength, lambda r is longer wavelength, right? So that's why v of that violet, the speed of the violet color in the medium is going to be less, and the speed of the red in that medium is going to be more, as lambda is longer, right? Simple. And now what is going to happen, since we are using the formula mu is equal to c, means the speed of light in that medium, by v, we can see that if we divide this, if the value of v is larger, the value of mu is going to be less. Refractive index for that particular light is going to be less. That's why, since the value of v for red is higher, the refractive index of that r, red color, is going to be less, right? And vice versa, as the velocity of violet color is going to be more in that medium, less than in that medium, sorry, so the refractive index for that is going to be more. Simple. From this formula you can see it, right? So that's what happened. For different wavelengths, the refractive index also changes, and the velocity also changes for different wavelength, or you can say for different colors, right? Simple. So this is like important concept in wave optics that you have to keep in mind.